All right, we're live. I'm going to introduce Ron Bonica. Ron is going to talk about enhancements to ping and traceroute, some implementation of two RFCs. What are the RFCs, Ron?
8335 and 5837.
Right, and there's kernel changes as well as user changes. A lot of fascinating stuff here. So I'm going to start the video. When the video ends, the usual, just post your QA questions on QA or queue the mic by raising your hand. And with that, we'll get started here, and Ron and I will disappear and show up after QA.
Hello, my name is Ron Bonica from Juniper Networks, and I'd like to talk to you a little bit about some work we did to the networking software, specifically some enhancements to ping and traceroute. And before we start, I'd like to give credit where credit is due. Most of the work was done by 4 undergraduates from Harvey Mudd College. They're all recent graduates now. Their names are Ishan Gandhi, Andreas Rosler, Spencer Lang, and Nick Ludwig. Their mentors were me, Ron Bonica, and Professor Zach Dodds from Harvey Mudd College. So let's talk a little bit about what we did. Ping and traceroute are the most commonly used tools in the IPOAM toolkit. If you work in a NOC, you use these tools all day long. We're going to talk about what they do, how they work, what they can't do, and how they can be enhanced. So let's talk a little bit about ping. Ping does 2 things for you. It tests the liveness of a reachable interface, and it can also test the liveness of a reachable node. It does this by testing the liveness of one of the reachable node's reachable interfaces. Now, you might notice that I've used the word reachable about 10 times in the last minute. What does it mean for a node to be reachable? Well, you're doing the ping from somewhere, a probing node, and the node that you're probing is the probed node. You need to have a route from the probing node to the probe node, and the probe node needs to have a route back to the probing node. Basically, you need to have bidirectional connectivity. And those words are going to be very important in just a second, bidirectional connectivity. So how exactly does this ping animal work? Well, the probing node sends an ICMP echo message to a probed interface. The probed interface sends an ICMP echo reply back to the probing node. Now, a few nerd notes. The ICMP echo message may enter the probed node through any of its interfaces. There's no guarantee that it enters through the probed interface. The ICMP echo reply message may leave the probed node through any of its interfaces. So there's no guarantee that either ICMP message traverses the probed interface. The message may go in and out one interface, but be asking about the status of another interface. What can't it do? Well, ping cannot test the liveness of a less than reachable interface or a non-interface reachable interface. Now, what exactly is a non-reachable interface? Well, one possibility is that it's an IPv4 unnumbered interface. In some cases, a device has many interfaces. You give one interface an address, and every other interface on the box inherits that address. That's called an unnumbered interface. Another possibility is that the probed interface is an IPv6 unicast address that is narrowly scoped. Say it's a link local address or a ULA. Well, yes, it has an address, but you don't have a route to a link local address that's a few hops away. And you may not have a route to a ULA or a private address. Or it could be just some normal interface with a normal address that you don't have a route to. That's a less than reachable interface. And ping, as it is right now, cannot be used to test the liveness of that interface because you can't reach it. You can't send a message to it. So how can we enhance this? Well, a few years ago, a few colleagues and I wrote RFC 8335. And in 8335, the probing node sends an extended ICMP echo request, an extended echo request to a proxy interface. The proxy interface must be reachable. The extended echo request identifies the probed interface. So you're sending an echo request to node A, asking about the status of node B. The proxy interface sends an extended ICMP echo reply to the probing node, and it reports on the liveness of the probed interface. So what's happened? You've sent an echo request to node A, asking about node B. Some node sends a response saying the status of node B is whatever. So here's an example of this kind of pictorial. Nick was one of the developers. He sends an extended echo request to interface 2 on this node, asking, how's node 3? And the response comes out of interface 2 saying, node 3 is up. Notice neither the incoming nor the outgoing message went through node 3. And in fact, node 3 was not reachable from Nick's machine. Now, a few nerd notes on RFC 8335, the probe application. The proxy interface can be different from the probed interface, and is different in most cases. You wouldn't use probe if they were the same. The proxy interface must be reachable from the probing interface. The proxy interface must reside on one of the following: the same node as the probed interface, or a node that is directly connected to the probed interface. And here is an example from Andreas's machine. Now, there are some security considerations around this. Maybe you do not want to be handing out information about nodes on your network to just anybody. So this application is not enabled by default, and it's generally protected so that it's only accessible from some source addresses. Now here's one of the problems that you might have. When you send an extended echo to a machine, you have to identify the probed interface somehow. Maybe you're doing it by address. Maybe you're doing it by name. And if you're doing it by name, you might be giving out other information about the node. For instance, if it has a node with a name of one format, it's one kind of router hardware. If it's a different format, it's a different kind of router or hardware. So this is something that you really want to think about before you enable it. There are some implementations. It's implemented on Junos. Junos is our company's routers. It's in the Linux kernel, 5.13. It's in a commit to Linux IP utils is in progress. It's also in Wireshark 3.5, and a TCP dump commit is in progress. So let's move on a little bit and talk about Traceroute. Traceroute elicits feedback from each node on a delivery path between a probing interface and a destination interface. It identifies nodes along the path. Now, what it does not do is identify which interfaces on those nodes the packet actually traversed. It'll tell you what nodes it was on, and it will identify those nodes by some interface or other. But the interface that the nodes are identified by are not necessarily the interfaces that the packet traversed. So let's talk a little bit about how Traceroute works. A probing node sends a series of UDP packets to a destination interface. On the first packet, it sets the TTL to 1, so it expires on the first node along the path. On each subsequent packet, it increments the TTL, so it expires on the next node along the path. When a packet expires on a node along the path, that node sends an ICMP time expired message to the probing node. Now, regarding those UDP probes, by default, the first packet is to UDP port 33434, and every subsequent probe increments the port number. That way it's easy to match responses with probes. Regarding the time expired message, what is the source address of that time expired message? Well, the source address of the time expired message may not be the same as the address of the interface through which the probe entered the node. That's why I say Traceroute identifies nodes along the path, not interfaces along the path. Generally, you look at the source message and say, oh, this is the interface that it visited. No, it may not be. In IPv4, that source address is the interface through which the ICMP time expired message left the reporting node. In IPv6, it's complicated. It might be that, it might be something more informative. CRFC 6724 for details. So, what can't Traceroute do? And that's identify interfaces along the delivery path. So, how can we fix this? Well, we still use the same old UDP probe message. We send a probe message, we increment the TTL, we increment the UDP destination port. The ICMP time expired message contains extensions that identify the interface upon which the UDP probe arrived, the interface through which the message would have been routed had the TTL not expired, and attributes of all those interfaces: name, IP address, MTU. And here's a look at what this looks like. Here we're doing a trace route. It goes through hops 1, 2, 3, and 4, and they don't have the extension. So they're just, 1, 2, 3, and 4 are legacy nodes. They don't have the extension to trace out route, but we hit 5. And when we hit 5, we get a little extra information in the time expired message. We know that the interface arrived on EN2, its address is 381549, and its MTU is 1500. Again, on node 12, we get the same thing. And I think what you're looking, yes, you are looking at a trace route through some nodes at Harding College. Now, again, security considerations. This is not enabled by default. Maybe you don't want to be telling everyone in the world what the names of your interfaces are or what their MTUs are. And it's accessible from specified source routes only. Again, we have some implementations. There's a Junos implementation in progress, a Linux kernel implementation in progress, and IPutils Traceroute in progress. We do have it in Wireshark. So when we say in progress, that means we have submitted the patches and are waiting for approval for them to be committed. With that, that's all we have, and we are open for questions.
All right. Thanks, Ron. Can you hear me, Ron?
Yes, yes.
Okay, yeah. So Okay, should we wait for more applause or that's it? Okay, it's done. Oh, well, geez. Okay, we shouldn't encourage this. Okay, there's one question from Michael, which I'm going to post on the screen here. If you have questions, please go to the QA or raise your hand, and you'll be placed in the mic queue.
Okay. Does the time expired message have space for the lat long router? Well, the time expired message can be extended. There isn't a TLV to put it in right now, but one could be defined. So yes, it is possible, but there's yet another question. Is it a good idea to reveal the lat long of routers? I assume for some operators that it may be a good idea, and for others not. If you'd like to explore this, feel free to send me some private email.
Michael, thumbs up if that was good. All right. Anyone else? So it wasn't clear to me. So the kernel changes, when you showed the example with I think it was Traceroute, and you showed two nodes. I think one was node 12, which one had a name for the interface, the other one didn't. They had an IF index, I think. Mm-hmm. There was a kernel patch in the source of where the Traceroute came from, or was there that was totally pure user space?
Okay, this was a kernel patch.
Okay.
And what's happening is normally you would send back an ICMP time expired message with no extensions. Mm-hmm. Two of these nodes had the kernel patch, so they sent it back with the extensions. And the extensions said, oh, here's some more information about this packet. It entered on EN2. EN2's address is such and such. Mm-hmm. Its MTU is such and such.
Okay, got you. So you need the kernel patch. So those are the only two machines that had that information. Right.
That. You need the kernel patch, and you need it to be enabled.
Right.
Remember, by default, it's not enabled because you might not want to be telling people. You know, when you tell somebody that your interface name is EN2,
yeah,
you're telling them it's not a router of this type or that type. You're mm-hmm. actually leaking a little bit about what kind of software it's running.
Okay, there's a question from Joel Samaru, if I say that right. There you go.
Okay, I don't see the question.
It should be on the screen.
Oh, okay. Yeah. Yes. Do you think to have a more parsable format for the extensions? Do you think having a more parsable format for the extensions would be helpful? Do you mean inside the ICMP message or in the user interface?
Okay. Do you want to come on the stage, Mike? Sorry, Joel. I can invite you. See if you want to just explain. Or type it on the screen. Okay, all right. So he doesn't have a mic.
Okay.
Okay, he's going to look for a mic. Okay, that's good. There's another, maybe I'll pop another question here and then we'll see if we bring it back. Okay, so that's the next question.
Okay, how many middle boxes already filter pings and trace routes? Well, now they have exactly two choices: send no information at all, or send the information that standard ping and trace route gives them. This gives them a third choice: send no information at all, and if they do that, fine. Send only the information that they can send today, and if they configure that way, fine. Don't enable this new feature. Or if they want to send more information, enable the new feature. So yes, they can still drop it, pings and trace routes because they don't want to give any information. They can hold, giving only the information they give today by not enabling the new feature, or they can enable it and send more, or enable it in a discriminatory way. Send more information, but only to the nodes that they feel are inside their trust domain, maybe their NMS. And by the way, that's true for ping, but not traceroute. Traceroute, you just have to disable the entire feature.
Mm-hmm. Okay. And Mikhail, is that a good answer? You are happy with that, or you want send me a thumbs up? Okay, good. All right, Joel is back, and we'll put him on stage now. Okay, so I'm going to show his question again, and then I'll invite him onto the stage. All right.
Can you hear me okay?
Yeah.
Yes.
All right, cool. So the question I had is, when I was looking at the traceroute slide, if they had the extension enabled, it looked like it was like multiple lines for the interface that came in, and I was wondering if there was a way that could be flattened out. So like if I wanted to filter with like grep or something like that with command line tools. Yeah.
You're talking only about the user interface, not about the ICMP message itself. Okay, certainly that could be done. And if you'd like to talk about that, again, send private email and we can work on it together.
Okay, sure.
Another thing that struck me is it might be a good idea for ping and traceroute to have a more parsable output like JSON.
Right, and I was getting that too, because with observability and all this stuff coming out, it is going to play, I think, a bigger role in global network observability and more real-time monitoring on that kind of front, I think.
If anybody's interested in that kind of project, maybe ping, traceroute, and some other utilities, coughing out JSON or XML or something like that, contact me privately, and that might be something worth pursuing. But
yeah, I mean, I guess we could also just use like a Python library to do it, or something. But I was just wondering if just the static message, if I was just like a quick and dirty trace route and I wanted to just pipe that into some, program in some structured data way, it would have been easier,
Yeah. Certainly, contact me offline and we'll talk about, maybe it really wants to be on one line instead of 3.
Thank you.
Okay.
All right. I'm going to bring a question from Shmolik here. And I'm going to remove Joel from the stage.
Okay, you've guessed it, Shmolnik. It is unlikely that public providers are going to want to leak additional info about their nodes. Things like their MTUs, their interface names. So if they enable it, they will probably do something like only enable it, but but filter the output so it will only go to trusted addresses like their own NOC. If it's going someplace other than that, they just wouldn't send a response at all.
Okay, so I think is the second part of the question. What is the use case that?
Oh, the use case is internal to the AS between the NOC and the network element that the NOC controls.
So it's your own network is probably where a lot of people use this for.
Yeah, that's what we were thinking.
Okay. Is that okay? I think Shmolik says he gives it a thumbs up. Any more questions? Yeah. So I guess deployment is going to take a while, right? Because you need kernel patches, and then you need to update, if I understand, all the utilities like Traceroute. Of course, if you have your own big internal network, this is easy. Everything is under your control. But for wider deployment, it may take.
Yes.
Have you pushed your kernels patches upstream yet? You said you pushed.
For extended ping, yes. For traceroute, in progress.
Okay. So the extended ping, what's the status of that? It's.
Oh, we had a slide, and I forget what it was, but it was in version. I want to say. Could we go back to that slide? I want to say.
I will have. Okay, I think I may be able to bring back the video again, and then we can rewind.
Oh, okay. It's. Let me look at it on my laptop.
Yeah, or
because there was a version number in there.
Yeah, you can share a screen. There's a share button there, the up arrow, if you want to just share one slide.
Well, I just have to find it, and I'll know the version number.
Oh, I see. I can also do this.
It is in.
Sorry. I just wanted to forward it. Whereabouts, you think?
It is in Linux kernel 5.13.
Oh, that's very new. Okay, that just came out.
Yes.
Okay, you're state of the art, Ron.
Yeah.
Okay. Any other questions? Comments? Okay, Justin said it's 5:13. Okay. Any other questions? Please post in the QA tab or raise your hand, and we'll hand you the mic. Okay. Going 3, 2, 1. Let's give an applause to Ron. Thanks for your time, Ron. And
thank you very much.
Yeah. Thanks.